Okay, students, welcome back to next session. Here we are going to see another technique used with operational amplifiers, that is sample and hold circuit. This sample and hold circuit is normally used in A to D conversion processes, and it is also very important circuit. So sample and whole circuits, and then we will see the data acquisition systems, data loggers, LabVIEW, and the PID controllers. So here, the sample and hold circuit is an electronic device that captures and holds a sample of an input voltage signal for a defined period. So the process consists of two key phases. One is sampling time, in which during which the circuit takes a snapshot of the input signal. So it takes a little amount of input signal, typically ranging from 1 microsecond to 14 microseconds. And holding time, when this circuit maintains the sample signal until the next sample is taken. So until the next sample is taken by the circuit, it holds the initially taken sample. And this functionality is crucial for converting analog signals into digital signals. So it is normally used in A to D converter, as it allows for the stabilization of voltage levels during the conversion process. A number of problems exist when the earlier sample and hold circuit. So here you can see a capacitor, and here it is taken, and when it closes, capacitor stores little less power here, and this is the very old type of technique. Now that is replaced by this technique using MOSFET. Here MOSFET and voltage follower, two voltage follower circuits are used. So this is the typical circuit. Here, the first in this circuit, the load placed on the input for of the circuit by changing the capacitor during the sample phases. So current flowing from the capacitor used in the conversion will reduce the voltage stored in the capacitor. So that is the problem. Sampling and hold circuits are used to store the analog value of the signal at the sampling instant during the analog to digital conversion time. So this is the improved circuit from this circuit. So sample and hold devices, sampling rules tells us at what rate to make conversions, but there is still another problem associated with the changing signals. So T1 to T2, so here this is T state and this is T state, and here this is the storage capacitor, and T1 to T2, here you can see this is little reduced time. To remove the problem, a sample and hold device which samples the input and holds this value until the end of conversion is often used. So this is the sample and hold circuit main usage. Next is its significance in communication. The sample and hold circuit plays a crucial role in digital communication systems by transforming analog signals into stable digital values. In analog communication, noise interference significantly affects signal quality, leading to the inefficiencies and unreliability. By sampling the analog signal and holding its value, the circuit mitigates the impact of noise, enabling clearer and more accurate digital representation of the original signal. So here, these are all the components used in a sample and hold circuit. So here, this is the MOSFET. The N-channel enhancement type MOSFET serves as the switching element. When a positive control voltage is applied to its gate, it switches on, allowing the input voltage to pass to the capacitor. So capacitor function, the capacitor charges to the peak value of the input voltage during the sampling phase. Once the MOSFET is switched off, the capacitor retains the charge, providing a stable output during the hold phase. So the op-amp role, the operational amplifier maintains high impedance, ensuring that the stored change in the capacitor does not discharge. It processes the output signal during the holding period and to the accurate signal representation. So that is the operational amplifier role. So input and output waveforms. So here this is sampling period. So here this is during the sampling period the input waveform is captured, resulting in a series of discrete voltage levels held by the circuit. This occurs when the switch is closed, allowing the capacitor to charge to the input voltage peak. So holding period here, in the holding period, the output waveform remains constant at the last sampled voltage value. This is whether the switch is open, preventing any further signal change while the capacitor holds the charge. So that is the holding waveform, and this is the sampled waveform. So here acquisition time, it is TAC, the time required for the capacitor to charge to the input voltage level applied to the sample and hold circuit, and aperture time TAP, that is the time taken for the capacitor to transition from sampling state to the holding state, affected by the switch propagation delay. And voltage drop, the decrease in voltage across the capacitor due to charge leakage, highlighting the importance of using capacitors with minimal leakage. And hold mode settling time, the duration required for the analog input voltage to stabilize after the hold command is issued, ensuring accurate voltage representation. So here applications of the circuit, it is used in data distribution systems where sample and hold circuits are used to capture and maintain voltage levels in data distribution systems, ensuring accurate signal transmission over long distances. So sampling oscilloscopes, it is used in sampling oscilloscopes. These circuits enable oscilloscopes to sample analog signals to precise intervals, allowing for accurate waveform representation analysis. In digital voltmeters also it is used. It helps the digital voltmeters to stabilize readings by holding and sampling sampled voltage until it can be processed and displayed. Analog signal processing. In analog signal processing, these circuits are crucial for converting continuous signals into discrete ones for further analysis. Signal constructional filters. They are employed in constructing filters that require precise sampling of input signals, improving signal integrity. So, in data conversion systems, sample and hold circuits play a key role in data conversion systems, which facilitates the conversion process of signals to digital form of the signal. So these are all the application areas of sample and hold circuits. So here a few terms which are necessary to know. Digital storage oscilloscope. It is a device that captures and stores waveforms digitally for analysis. Sampling oscilloscope is an oscilloscope that samples analog signals to discrete intervals to analyze signal characteristics. Peak detector, a circuit that captures and holds the peak value of an input signal using a signal processing. RC and RL circuit. RC circuit use resistors and capacitors, while RL circuits use resistors and inductors in various applications. Shockley diode. It is a semiconductor diode used in switching applications, demonstrating control in voltage and current. So these are the terms you should aware of in terms of sample and hold circuits, and these are the very important terms. And textbooks, this is given in the same Rai Chaudhary book, you can refer. LIC by Rai Chaudhary book, and other books are same textbooks and references given in the syllabus. E-resources are also available. So we stop here, students. We will meet again in next session. Thank you. Thank you, students.